So I thought we would get radians out of the way. So it's just one of the things that I like about this trick book we're using is that they're introducing radians fairly late in the game. And radian measurement doesn't make a lot of sense until there is a moment in calculus, actually. It's fairly early on in calculus, but not before. But I guess we can make an argument for, well, maybe radians are necessary for graphing functions, trigonometric functions. So I guess I can live with that. And I usually get radians out of the way so you guys can read all the other trick books that start with radians right away. Radians is just a way of measuring angles. Let's start with an angle that's between 0 and 360. And then what we do is step 1. This definition is going to be similar to the right triangle trigonometry definitions, where you had to measure things and take ratio. So step 1, draw any circle at all. And step 2, measure. Now you see why I insisted that it should be between 0 and 360, because we should be able to measure it as a central angle. And now theta measured in radians is going to be a following ratio, just like sine of an angle would be. It's this arc length divided by the radius. And if the radius happens to be 1, then the arc length is the measure of the angle. In fact, you know, you understand what this is. Don't tell me how much this is, but you understand what this is asking about. I hope. It's basically asking of an angle whose sine happens to be 1/2. The calculator will probably say 30 degrees, right? But there's another notation for that, and it goes like this: arc sine of 1/2. Well, that arc is not like an abbreviation. That's the arc length, because in the unit circle, the arc length is the angle measure, right? So this is that arc length in the unit circle. And so notice that no matter how we measure the length, when we divide the length by another length, the unit cancels out, and this is a real number. So we can find 360 degrees in radians. The definition is the arc length divided by the radius. So 360 degrees in radians is 2 pi r divided by r, where r cancels out, and we get 2 pi. And what I like to do is divide both sides by 2, and then this is the thing to be memorized. 180 degrees equals pi radians, right? We just get rid of the 2. But usually mathematicians or physicists are kind of mean, and it's just an extra courtesy to say radians, because radians are unitless unit. It's a real number. So usually you're just going to see 180 degrees is pi, and that's pi radian. Okay. And then now we can figure out angles that you cannot measure in circle if we just insist on this and we scale things based on these ratios. So we can now convert any angle to radians. It's basically a sort of a ratio problem, although that's not what I do. For example, well, do you guys know about conversion factors or unit multipliers? I don't think you really need that, but you know, 60 minutes equals to 1 hour. And that gives rise to 2, if you're young, conversion factors, if you're old, unit multipliers. 60 minutes divided by 1 hour is a fraction with value of 1. And so is 1 hour divided by 60 minutes. And these are called conversion factors. I like that name because it tells you that we are multiplying by these things and we use it to convert. And unit multipliers, I like that name too, because unit is just a fancy word for one. These two fractions have value 1. And guess what? We're going to multiply by them. So if you want to convert, say, 1200 hours to, that, I don't know. I'll come up with a more mysterious number. How about 720 minutes to hours? Then you start with your 720 minute. Oh, and we grow a 1. So now it's a fraction. So we're going to exploit properties of fractions. And so, well, you can write down these two unit multipliers, but basically what we want to do is we want to cancel out the minute and bring in the hours. So the moment you decide that the denominator should have minutes, then you know that it's this one. It's 1 hour divided by 60 minutes. And then minute is canceled out. And now we have hour. 12 hours probably. Yeah. So it's 720 divided by 60 hours, which is probably 12 hours. I intentionally use something that you know very well. So one way, but I don't think you're going to need this for long, is to use unit multipliers. So for example, convert, let's see, 450, that's just, okay, degrees to radians. You can say 450 degrees times, now the degrees comes downstairs to be canceled out, and then pi radian divided by 180. Yeah, I forgot to mention. 180 degrees equals to pi radian, so we can write 2 conversion factor out of it. This is one of them. This is what we use to get rid of radians, bring in the degrees, and this is the other one, which we use to get rid of the degrees and bring in radians, right? And so most often you're going to be asked for exact value, which means you cannot use decimal. So it's just a matter of simplifying this fraction. That's how many pi. And I see 90, that they are both multiples of 90. This is 5 times 90. This is 2 times 90. So it's 5 pi over 2, or 5 over 2 many pi's. So that's one way. And then if we want to go 4 radians to degrees, that's 4 radians. We grow 1, and then we want to get rid of the radian, bring in the degree. So pi radian is 180 degrees. And it's probably, if they ask for exact value, then it's 360, 720. 720 degrees. 720 divided by pi degrees, which is a little bit more than 240. Actually, you know what you should know how. Let's figure out how many degrees is 1 radian. 1 radian is how many degrees? Now I want an approximate value. How many degrees is 1 radian? 1 radian is how many degrees? 57 and change, exactly. So, you know, it kind of makes sense because let's go first with 60 degrees. If this angle is 60 degrees, this is a regular triangle. This is, all 3 sides are r long. And hopefully you have an instinct that this arc length here is just a little bit longer, right? This arc length is just, this here is a little bit longer than this radius. So if we want the arc length, if we want the arc length to be equal to the radius, we have to close this down a little bit. We have to decrease 60 degree just a bit. Does that make sense? 1 radian means that the arc length is exactly the radius. Now, this one is longer than the radius because this chord is radius long in case of 60 degrees. So we just have to close this in just a few degrees so the arc length becomes as long as the radius is. And that's a good fact to keep in mind, that 1 radius is 1 radius times 180 degrees divided by pi. Now, pi is 3 and change. If it was exactly 3, this would be 60, right? But pi is a little bit more than 3. So 180 divided by pi, that is your 57 and change. So to me, so radians are heavy. Like 1 radian is almost 60 degrees. So the same angle expressed in radians is a much smaller number. After a while, you will have an instinct that if you go from radian to degrees, we have to grow that number. So you multiply by 180, divide by pi. And if you have to go from degree to radian, then we have to shrink down that number considerably. So we divide by 180 and multiply by just pi. That was enough for me when I was a student to know whether to go and grow that number or shrink it using 180 and pi as multipliers or divisors. So this is a useful little fact, that one radians is about 57.3 degrees. Now, let me show you how I convert stuff. What I think what you're going to need very soon is when someone says, solve this equation, sine alpha equals half. I think the fact that this is a Greek letter suggests that alpha in radian in degrees is okay. But when you see something like sine x equals minus square root of 3 over 2, x is a real number, then it kind of suggests, and that's usually the rule, that you should present your answer in radians. Till this day, I pretty much think in degrees, and I just translate, and I solve the problem to the bitter end in degrees, and at the very last step, I just convert it to radians. And the way I convert things is I don't really use the x. So the way I do it is I try to take back everything to 180. So for example, 60 degrees, I think of it as 180 divided by 3, therefore it's pi over 3. Because 180 is pi, that's kind of the magic rule. 180 degrees is pi radian. So how would you convert without conversion factors? How would you convert 90 degrees into radians? Or what do you get?
Well, it's 1/2 pi.
Right. So it's yeah, exactly. It's half of 180, therefore it's half of pi. Just pi over 2. Exactly. And then, for example, 30 degrees, it's good if you know your divisibility. 30 degrees is a divisor of 180. 180 divided by 6, right? So it's pi over 6. And in fact, now I can say officially that arc sine of 1/2, it should be pi over 6, not 30. So it's supposed to be, the official language of trigonometry is radians.